Sound in Medicine. General Properties of Sound Wave. By Assistant Professor of Medical Physics Dr. Al-Arif. The nature and characteristic of sound wave. Sound is a longitudinal wave in air propagated with wavelength, lambda, frequency, f, and speed, v. The energy is transmitted by pressure changes in the molecules of the medium due to the collisions. Longitudinal wave means that the wave generated moves in the same direction of vibration of the molecules. Tuning fork producing sound. As you can see in the figure, when the tuning fork continue to vibrate, molecules of the medium also vibrate and collide with each other, producing a succession areas of compression and rarefaction pressures spread out away from the source. A sinusoidal curve can be fitted to represent the longitudinal wave, in which crests, top, correspond to compression and the troughs, bottom, refer to rarefaction, as in the figure. The sound speed, v, is equal to the multiplication of the frequency, f, by the wavelength, lambda. Note, the product of wavelength and the frequency is always constant value for specific sound wave. The speed of sound in any medium depends on 1. Molecular structure of the medium, solid, liquid or gas. 2. Temperature of surrounding. 3. Density of the medium. The speed of sound, density and the acoustic impedance of the medium are related to each other as shown in the table below for some important materials for human body. The table shows that the velocity increases with density and acoustic impedance of the materials. Z is the acoustic impedance, representing the reciprocal of the resistance of the material to wave motion, and is given as the multiplication of the density of the medium by the velocity of sound in that medium. The speed of sound, density and the acoustic impedance of the medium are related to each other as shown in the table below for some important materials for human body. The table shows that the velocity increases with density and acoustic impedance of the materials. Z is the acoustic impedance, representing the reciprocal of the resistance of the material to wave motion, and is given as the multiplication of the density of the medium by the velocity of sound in that medium. Solved example. Please follow the solution carefully. Solved example. Please follow the solution carefully. Energy and intensity of sound. Sound energy, E, and the intensity, I, are directly proportional to each other and inversely with the square of the distance from the source of sound, as shown in the following relationship. The intensity, I, is defined as the power, P, emitted per unit surface area, A, and is given by the following equation. Please notice the unit for the intensity, watt per square meter. Solved example. Please follow the solution carefully. The intensity of plane wave in terms of the acoustic impedance of the medium, Z, is given by the following relation, where A, here refers to the amplitude, not the area, and omega, is the angular frequency, which is given by the frequency, f, multiplied by 2 pi. Sound intensity can also expressed in term of the change in pressure, delta P, between compression and rarefaction, and is given by the following equation. As you can see from the figure, the intensity of sound, I2, at distance, R2, from the sound source can be found in terms of reference intensity, I1, at distance, R1, according to the inverse square law, which is given as the ratio of I1 to I2 is equal to the square the ratio of R2 to R1. Human frequency range. Human sound system operates within certain range of frequencies. Human voice, from 64 Hz to 2050 Hz. Human ear audible range, from 20 Hz to 20,000 Hz. Below audible range is called infrasonic. Above audible range is called ultrasonic. Human frequency response curves. The human response curve shows the limits, upper and lower, of the intensity levels that can be detected by human ear as a function of the frequency, as can be seen in the figure. The bottom curve in the figure is the threshold of hearing, which is strongly dependent on sound frequency. Easiest frequency to be heard is at about 3,300 Hz. The top curve is the threshold of pain, where all frequencies can be heard about equally degree. The curve is nearly a straight line for most frequencies.